Okay, fine. Let's see, consider the logic circuit shown in the figure in which A, B, C are the input and Z is the output. Last week we discussed this one, no? Is that a discussed one, no? Yes. Consider the logic circuit shown in the figure in which A, B, and C are input and Z is the output. So let's see. Give the complete truth table for the given circuit diagram. Okay, first of all, give me a minute. I'll just draw this diagram. So this is the session. Now it's a question number past paper 2020. So let's discuss about this. Give the complete truth table for the given circuit diagram. First, let's see. Okay. Now you can see the truth table. Let's see how to do the truth table. But the truth table concept is very easy. In the truth table and the area, it's easy. Okay, but the problem is Karnaugh Map SOP and Karnaugh Map POS. This is a concept that I want to mention. Here, what we are going to do, A, B, C. How many inputs are there? A, B, C. And the Z is the answer, sorry, output. So this is your truth table style. So you know this is called as 2 to the power 0, which means one input 0, 1, 0, 1, 0, 1, 0, 1. So 2 to the power 2 is equal to 2 outputs, two combination 0, 0, 1, 1, 0, 0, 1, 1. So the A is equal to 2 to the power 3, which means 4 outputs. 2 to the power 3 is equal to, sorry, 2 to the power 2 is equal to 2 to the power 0, 2 to the power 1, 2 to the power 2. 2 to the power 2 is equal to 4 inputs, 4 zeros and 4 ones. Okay. So this is your truth table combination, number 1. Fine. Let's see, is there any definition that they have given? Okay, here there is no definition. You can get the answer from this one. So with the combination. So number 1, A, B and B, C combination is there, and thereafter C is input. So this is your diagram. So here, let's check combinations. Just A plus, here this is A plus B, here B plus C, and this is your C. So the total end is A plus B and B plus C and C. So this is your combination. So the A plus B is there. So A plus B and B plus C and your C. Okay. So the A plus B is equal to 0 plus 0 is equal to 0. 0, the final is delta. A plus 0, 0, 1, 1, 1, 1, 1, 1. So B plus C next one. 0, 1, 1, 1, 0, 1, 1, 1. Now the C, so you don't need to write the C directly, you can get the C from the table. So the Z. Now here directly you can say 0 into 0 into 0 is equal to 0. You know this one 0. This is 0, 0, 1, 0, 1, 0, 1. So this is your answer. That answer is this. Okay. So this is your answer. Now let's start with this concept, truth table concept. So from this truth table, we are going to draw the Karnaugh map, and the Karnaugh map concept that we are going to use it in a two different concepts. Number one, SOP by using that SOP concept. Number two, POS concept. So this is our main question. Okay. Let's see your question number 5. The A part is completed. This is a truth table. And using a Karnaugh map. Now let's draw the Karnaugh map for two different concepts. So the Karnaugh map drive a simplified sum of product expression for the output Z. Number 1. C part using a Karnaugh map drive for simplified product of some expression for the output Z. Okay, let's see. So in this question, now let's draw the Karnaugh map diagram for this. So here you have a three combination. You know that concept. If it is a one input and a two input, you have a combination of 0, 1, 0, 1. So if it is a B, there is a two combination 0, 0, 0, 1, 1, 1, 1, 0. Okay. So this is your Karnaugh diagram. So I'm going to develop a SOP concept, sum of product concept. So sum of product here only the place A plus A minus A0 B1 A0 B1 here, and the C is equal to here this one. For the sub part, number 1, number 2, number 3. So these are the sub. So we call as A bar, B and C. So here A, B bar and C. So here A, B, C. These are the combination. So A is equal to 0, B is equal to 1. So and C is equal to 1. So this is 1. So the next one, A is equal to A1, B0, A1, B0, and this is C. Yeah? This is A, this is B, this is C. So A, B, C. So 0, 1, 1. So next one 1, 0, 1. 1, 0, 1, which means A is equal to 1, B is equal to 0, and C is equal to 1. So this is the area. And next one, here A, B, C, all are 1, 1, 1. So this is your Karnaugh Maps. Clear? For the SOP. At the meantime, I'll just draw this POS concept also. POS. So even you can take the same drawing, but to avoid the confusion, I'll just use this. A, B, C. So 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. In this first concept, we are only taking the zeros. Okay. So let's discuss. Let's see this. So A, B, C. All are zeros. A, B, C. This is 0. And A, B, C. This is okay. Second one. A, B, 0. And C is equal to 1. 0. And this is also fine. So this one. A0, B1, C0. A0, B1, and C0. And next one, A is equal to 1. Sorry, this is 1, 0. A is equal to 1, B is equal to 0, C is equal to 0. This is also fine. So the next one, A is equal to 1, B is equal to 1, C is equal to 0. So this is your combination of POS. So even you can write it down in a one single way, but it's not it's complicated. That's why I write it down. I wrote this one in a different manner. Okay. So let's see how the combination is working. Okay. You know that one 2 to the power concept that you have a grouping. So maximum number that you have to combine. You have to round it up. Looping. So in here, so number one, this is number one area and number two area. But in here, you can round up this one and this. Okay, let's see. So this is also, you know, this is easy. But the problem when you are writing the SOP, that expression only, we will get some issue. Let's see. SOP we, as we know, so directly you can apply. So here the first combination is this, and the second combination is this. Okay. So the best combination says now, so if the 1 is there, we are taking as a positive, which means A. If it is 0, we are taking as a negative bar value. Okay. Let's see. Let's concentrate on this one. It's very important. So if the value is 1, because we are only focusing on the 1, we are neglecting the zeros. We are not taking the zeros in the SOP concept. SOP, sum of product. So the sum of product means, you know, the sum of product, we learned a lot of things. So the sum of product means your summations are there with the product. AB plus AC plus. So this is what you call as a sum of product. So the products are there. In between the products, you are using a sum. Okay. Okay. Now let's see. In this manner. So you can write it down. The first number, this one is equal to A bar B. So this is A bar B and C. So number one, A bar B and C plus. So next combination, your A, B, C. So in here, you can write it down 1, 1, 1. So A, B, C plus A, B bar, C. Okay, so this is your combination. Let's take how to summarize this one. The first group, this is the first group, this is the second group. A bar B C plus A B C. Look at this carefully. I hope you know this how to do this one. I will just take this. So the second combination A B C plus A B bar C. Okay. So these are the combination. I will just take this. Now what you can do, A bar BC and ABC. So here the combinations are there BC, so you don't need to write it down. Plus here this is okay. So this is the group 1, so this is group 2. A B C A B bar C. So no need to write this one AC. So this is very simple. So your answer is BC plus AC for the SOP. Okay, my dear students, I hope you can understand this one. Okay, let's start the POS area. So POS combination, there is a small difference are there. I'll explain it. So the combination first, here the POS means, I already explained that SOP means this. So the SOP means this. So the SOP means this. POS means point of product of sum. So the product of sum means we learn the A plus B. Your summation, your sum is going with the product A plus C and so on. This is the sum. You understand? So POS means product of sum. You are producting the summation group. So A plus B dot A plus C. This is your example of the product of sum. Fine. Now let's do this work for this. Here number SOP. I already explained this one. So okay, let's place this. Here, my dear students, be careful. The one is negative mark. The 0 is positive mark. So this is the main concept. Two concepts are there. Number one, in the POS, you should consider that one. The first one is your combinations. How to write the combinations? Product of sum. So the product of sum means you are producting, you are multiplying the summation group. Clear? Number one. Number two, in here we are taking the zeros as the positive. Minus is the negative. Minus means the one is the negative. So here we use the A bar means, but in here the 0 is the A, B is also A. So here A, B. This is C. So A, B bar and this C. So here A bar, B bar. Here A bar, B. So here C bar. So this is how you have to take. So let's see how what is the group of this. A, B, and C. First group. A plus B plus C and A plus B bar plus C. This one. And A bar plus B bar and C. Here A bar plus B plus C. So secondly, A, B and C, first one. And second one, A, B, C bar. So you know this is a AB. A plus B plus C. A plus B plus C bar. So the answer is, you can take it that A plus B, the product. Now let's check. Here, two A's are there, two A bars are there. So you can cut it off B, B bar, B bar, B. So the balance is C. So dot C. So this is your first answer. Okay, my dear students, your sub answer is B, C plus A, C. Your first answer is A plus B dot C. Do you understand? Is this clear? If you have any other doubt. Okay, here look at this, the final one, D. Of the two expressions, SOP and POS, you obtained in B and C above, which one is better to implement a more simplified logic circuit than the given logic circuit above? Explain your answer. Okay, this is one of your argument for justification. So let's see. So I just raised all of the thing. Now I need only this, SOP and POS. I'll show you. Okay, let's see. I just raise this. Okay. Look at this. Your sub answer is B, C plus A, C. Your first answer A plus B dot C. Now the question is, which one is, I think, yeah, obtained in a B and C. So this is your B answer. This is your C answer. Your B and C. Which one is a better to implement a more simplified logic case? Okay, let's see. Okay, my dear student, before I argue with this justifying things, you just look at that one. Here you have a BC is there. Let's see when you apply the BC. Here B is there, C is there. This is the sofa. Okay, B is there, C is there. So this is and A is there, and C is there. Here look at this. So this is your product of sum of product answer. Clear? Product of sum. First, let's see. Here the A is there and the B is there. Now C only working with this. Okay. So as you look at this one, directly you can say what? Which one is very simplified? Here you have a two AND gates and one OR gate. But in here, only a one OR gate and one AND gate. So therefore, your answer is the POS. This is a simplified version. It's a simplified version. So, number one, what is the justification? How you can explain it? Even you can draw this picture and you can explain it. As it is, you see in this one here, BC crossing with the one product. You have a two product and one summation. One AND gate is two AND gate is there. One OR gate is there. But in here, you have only the two types of logic gates, logic circuits are there, which means your OR is there, AND is there. So due to that, this is a very simplified rather than this. SOP is first is the better implementation, simplified version than the SOP. Is this clear, my dear students? If you have any other doubts, you can ask. So this is the basic concept of the SOP and the POS. Why we are using a SOP and the POS? In the generally, I can summarize that one. You know, so we have two types of things. Two types of mechanisms are there. Number one, the Boolean algebraic. Number two, Karnaugh Maps. So in the Boolean algebraic, you have a 9 laws are there. In the idempotent law, distributive law, identity law, and so on. So okay. And but this one in your Karnaugh Map, we have a typically we are using a POS SOP. Okay, sum of product. So in the zeros we are neglecting. But in these type of argumental point, we can take it as this SOP and the POS. But instead of taking the ones in the SOP, we are taking as a zeros in the POS. Why? Because there we learn about the max term and the min term. So one is a min term, zero is a max term. Due to that one, the concept SOP and the POS is also coming from that concept. So you know these are the theory area. So in your Karnaugh Map, we have two types of concepts are there. Number one, SOP. Number two, POS. So in this SOP, we are using a min term. In the POS, we are using a max term. So therefore, in our Karnaugh Map also, I explained how to summarize that one. So the combination, we are taking as the max term as a positive, min term as a negative. Sorry, in the POS area, 0 is the positive, 1 is the negative. But in the SOP,